Recording in progress. Okay, so we are now recording. Okay, so let me share the screen. We're going to go to Brightspace. All right, so you should be seeing Brightspace, and let's just go to the floor over here. Let's just check out the schedule. All right, so we are in module sniffing. Remember, you have a homework assignment due tonight, which is the SCAPI H.D. Moore case and the SCAPI problems or examples. So make sure you submit that. And then this week we started the topic of sniffing the network. So I went over these documents, and basically you have here, as you can see, two assignments. One is sniffing in C++. The other one is sniffing in Python. Okay, so if you have any questions about this today, we can go over it. My goal today, my main goal, is really to work through the H.D. Moore case, which hopefully you guys have completed or are working on. So that's my plan. All right, so let's go ahead and start reading through that again. And then we will, and actually let me start my virtual machine. So we're going to need the VM for this. And then you guys are still going to need to create some scenarios. You need to simulate somehow. You know, what I mean by simulate is, you know, literally generate packets, show evidence that your solution would work in a controlled way, at least. But so definitely want to see that. All right, so while the VM is loading, let's go to the case. I think, where is it here? All right, so yeah, there we go. So H.D. Moore's, you know, how he solved the Pentagon's dilemma. So this is what we want to take a look at. So the Pentagon faced a serious crisis against its computer networks. It was under a coordinated series of sophisticated attacks. Let me just make sure. Am I sharing this? I may not be sharing. Yeah, I just noticed that. Sorry. Sorry about that. All right, so I should be sharing now. Sorry about that. So the Pentagon was under a coordinated series of sophisticated attacks. A tool released, Nmap, made it rather easy for anyone to scan networks for services and vulnerabilities. The Pentagon feared that some attackers were using Nmap to identify and map vulnerabilities in the Pentagon's massive computer network. So an Nmap scan proves rather easy to detect, correlate to the attacker's address, and then geolocate the IP address. However, the attackers used an advanced option in Nmap. Instead of just sending scans from their specific attacker addresses, they included decoy scans with fake IP addresses and faked information that appeared to originate from many places around the world. So the Pentagon experts had difficulty to distinguish between actual scans and decoy scans. So this is really the problem, right? And so this is what we want to address. So now we're going to switch over to the virtual machine. You can see that here. So you should be seeing the VM now. I'm going to go ahead, maximize the screen. All right, so the goal then is to find a solution and preferably, you know, to automate a solution, right? So we're going to write a script as we've been learning with SCAPI, etc. So let's open up the terminal. Do an ls, desktop, ls, cd, its 454. Oops. All right, so H.D. more PY. Did I already? What's in that? Okay, I guess, yeah. I did give you something last time. All right, so let's start working through that one. So we'll just use that script then, okay? So the idea is, how do we detect these, right? So one suggestion that we made last time was the TTL, right? So basically, we want to understand what it was back then. We're going to make the problem simple. Assume that you can't randomize TTL. So the TTL, it's not randomized like the IP addresses for those problems. So it's the TTL is a field of the IP packet, right? It's in the IP header. We've seen that. The TTL field contains, can contain values in it. And then when a computer sends an IP packet, it sets the TTL field as the upper bound of hops a packet can take before reaching a destination, right? Every routing device that touches the packet will decrease the TTL. So that's kind of, we can think of it as our simplified definition of this. So if the field reaches 0, then the router discards the packet to prevent an infinite routing loops, right? So you basically drop the packet at that point. You just don't forward the information anymore. So let's think about the possibility of pinging something. So I'm going to go ahead and ping, let's say, and I'm going to specify here a TTL value for this packet, for these packets. So then I'm going to ping the Google DNS server. I want to be careful with what I do with Google here because I don't want them to block me, but let's do that. And we can see that the TTL there is 56, right? So TTL is 56. So basically here, if we ping the 888.08 address with an initial TTL of 64, and it returns, let's say, a TTL of 56, you can see that the packet crossed, that many routers. The difference between 64 and 56, which is 8. Is that 8? All right. And so that's kind of the intuition. And so that's the intuition of H.D. Moore, that, fake packets would not have accurate TTLs, and only the real packets, that came from the real place, would have accurate TTL. So what he was proposing is some kind of a ranking system or a filtering technique. So if we take a look at this, we can take a look at in the whiteboard. So you should be seeing the whiteboard now. So let's take a look here. All right, so the idea then, you have packets, right? A whole bunch of packets. They all have TTLs. And if we go to Google, we crossed like 8 routers, right? So we had a specific TTL, but other ones will have different values for the TTL. So what Moore wanted to do was, if this is point A, point B, the packets are coming from the attacker, right? They hit Moore. When Moore gets the packet, he grabs the information and sends it back out. So sends one packet back to the originator, right? And now the trick is, Moore is going to capture here the source IP and the TTL, right? And then on the sending packet, he's going to basically send it now to that same source IP and calculate what the TTL is, and then compare both, right? And if they're close, so he doesn't go like perfect, but if they're close, then those things are going to be filtered out. So it's going to be, the whole thing is about the difference, the difference of received TTL versus, let's call it Rio. That's the same letter, right? Let's use source versus the real TTL. So he's going to take the difference between those, and then basically he's got like a threshold. So the ones that are closest are going to be considered real, right? Because they're close. So it's probably a match. So then when you rank these values, let's say this is 2, 1, but then this is like 4, 8. And so he's going to create a ranking system. This should actually be 2. And so now the people, the system administrators at this organization, A, are able to focus their attention, right? So they don't have to worry so much about this group. They're not going to worry about this group, and they can start focusing their attention on those source IP addresses, and then via geolocation, they can basically go and arrest whoever is doing that, right? If they've committed a crime, or at least investigate them or something like that. Okay, guys, so that's the idea. Are there any questions so far on this concept? Is it clear for everyone?
Yeah.
All right, great. All right, perfect. So that's the idea then. And so now, obviously, what could the attackers do to make it even harder for them to detect? What do you guys think? What could they do?
Change the TTL, the source IP, or the genuine IP, so it gets flagged as a decoy as well.
Right, not include the real IP, right? That's one thing. That's what
No,
you
I mean,
said?
no, changing the TTL of the real IP to where it still gets flagged as a decoy, because Nmap actually does that now, where
Oh, that's right. So you
it'll
mean
randomize.
like instead of putting in like real, even there, like randomize them, you mean, correct?
Yeah, so you can in Nmap now it automatically randomizes the TTL of even the original source IP as well as the decoys to get around this.
Okay, great. That's a great idea. Great suggestion. So now let's go ahead then and think about how we're gonna address this and write the code. So we're gonna write the script for this. Give me a sec. All right, so let's take a look at the code. All right, so we can start with the function that I had already given you, which was pretty complete, I think, or not pretty complete, but it was a good skeleton, if you will. All right, so let's switch back to the VM.
Professor Calix, you still on PowerPoint?
Yeah, sorry about
Whiteboard.
that. Yeah, I'm switching now. So now you should be looking at the VM, okay? All right, so let's take a look. So HD more, right? I'm gonna just open up that one. HD more. All right, there we go. So from Scapy, all, import all. And we've already learned that because the packets are coming in, right, we want to grab them, sniff them, and then we want to, basically sniff and spoof, right? If you think of the terminology to be consistent with the book or the labs, we're doing sniff and spoof here. So we have here sniff, the filter expression that we need to use. What do you guys think we should use as a filter expression? What do you guys think?
Time to live.
The what?
The time to live.
On the filter expression? The filter expression is the type of packets that we want to look at. So we definitely don't want just like IP packets, correct?
Right.
The
What do you
filter
think?
the filter I used in mine was just to, just the filter, the decoy IP is being used in the source IP. That since we're just doing testing, obviously in a
True, that's true.
legitimate
So,
environment, it doesn't work that way,
right,
but
if you were doing, right, that's a good point. So you knew something about the target, maybe, correct? That's what you're saying? You only use the target IP?
yeah, I just put down the decoy IPs and the source IP just for testing, so that way nothing else got in the way, but in a
But if,
real
but I guess
environment.
if you were collecting more, let's say, you know, what would you put down here? Probably
Probably ICMP.
ICMP, right?
MPAM uses ICMP packets.
Yeah, ICMP. Okay, good. So we've got the filter expression. Now we need to specify what do we do with the function, right? So, so obviously every time we sniff a packet, we're going to grab it and analyze it. So we create a function, test the Ttl value, right? We created that function. So we go over here and we define it, test the Ttl value, and we provide in here a packet. So if you notice here, what we need to do first is we need to sniff the packet, you know, some of the relevant fields. And then after that, we're going to need to, you know, we're going to need to process the data. So let's do, let's put in here if, so we're going to do an if statement, if pkt dot has layer, and we're going to say IP. So if it's an IP packet, okay, let me actually delete these because they're going to confuse me. Okay, so if it's an IP packet, what am I going to do? I want the IP source, IP SRC, which has to come from the packet itself. So now I'm copying, this is where I'm copying the packet or the contents of the packet. So I'm going to do pkt dot get layer IP. Okay, dot, and then what do we need? We need the source IP there. And obviously I have an error here. So don't forget the indentation, 1, 2, 3, 4. Okay, so I've got that value in here. What else do I need? Probably the actual TTL, right, from that packet. So I'm going to do, pkt dot TTL. Okay, so that's the other parameter. This may need to be a string or an integer, etc. So we're going to typecast it. For now, let's just typecast it to string. All right. Now that we have these values, we need to figure out what to do with it, right? So we need to check it. So let's create a new function, check TTL. And this is where we're going to do that difference, that comparison, to see if we can, you know, filter these out. So check TTL. We're going to plug in here IP source SRC, comma TTL. So we've got both values in there. And for now, let's just keep it that way. Keep it simple. I'm going to add a line here. All right. And now we need to define that function. So I'm going to create another line. All right, now I'm going to define here that function I just created, check TTL, takes two parameters, right? The IP source and the TTL. 1, 2, 3, 4. Now, what's the next thing we need to do? We need to create a packet. So now we're going to spoof our packet, and we're going to send it out. So let's call this packet spoofing or spoof. Right. This is the packet that we're sending out. All right, so this is the packet that we're going to send out. We learned that to create these, we call the headers, right? So we're going to call an IP header. We're going to call an ICMP header, right? And maybe some additional flags. But for now, the only thing we need to specify is okay, you guys tell me actually. What will we do here? What would be the logic?
DST equals IP source,
Why?
because you're trying to send the packet to the original location in order to see what the TTL is.
Exactly. Very, very good. Very good answer. So now we're going to send it back out. So we're just going to use their data, right? We'll be using this trick a lot, right? So there's several problems that are very similar to this. So there's several variations. All right, so we're creating the packet. We define that the destination is the IP source. We know it's an ICMP packet. Now we're going to go ahead and send it. We saw some functions. One of them was SR1, right? So I think we saw those last week. And now we're going to send our PKT spoof, right, with some parameters, and then we're going to have result packets. This will give us a response, or should give us a response at least. Let's see. So let's define some parameters. We can leave it like this, I think, but retry, set it to false. Let's just try that. Timeout equal 1, and so on. All right, so once we have that, we have the TTL that was the original one, and then we have the resulting packet. So what's going to happen if we think about this logically, right? So let's go back to the whiteboard, go over here. So can you guys correct me if I'm wrong? Okay, so let's see. We have A, B, and let's say there's like, these are the routers along the way. Let's just say 4. So it came this way, right? And it said that TTL was what? I don't know, just some number, 17. But now we send it back, and it turns out, right? You know, it's set, let's say, to 64. It gets all the way over here. It went through 4 routers, so it would be 60, right? So we figure out that the TTL was, you know, around 4 difference compared to the 17, and it doesn't. There's a big difference there, so we should discard it. Do you guys see? Do you guys agree?
Yes.
Okay. All right. Yeah. So I just want us to think about this because, you know, it might be a complex thing to understand. So now let's go back to the code then and think a little bit about how we would write that. Right, so let's go back to the script. All right. So you guys should be seeing the virtual machine. All right. So the trick is here, right? In the next step, we need to figure out what we're going to say. So this res has a TTL value, right? So that's what we would need. So let's call it, I actually want to do this. So let's say this one is original TTL. And then now we're going to create actual, maybe actual TTL. And it should be res underscore pkt dot TTL, right? So now we have these two TTLs in question. And so what we might want to do now is compare them, right? So I'm going to say if, okay, something like that. And I say original TTL minus actual TTL. Right. Now those are, if those are not integers, let's just convert them to integer. Right. Yeah. So let me do that. So now I have a way of taking the difference. The difference could be this, like this could be 17 and this is 5, or this could be 5 and this is 17. So it'll come out negative or positive. But what is it that you need? You just need the difference between the two, correct? So the ones that have the greater difference, regardless of sign. So what can we do to get rid of the sign?
ABS.
Absolute value, correct? Or something along those lines. We can also square it. That would also work, just to get rid of it. And then this will give us a value. And then what do we do with this value? All these values need to be stored and then ranked, correct? So we need to, because we want to be able to rank them somehow. So what do we store? We need to store
Hey, Professor,
yeah, go ahead.
if you don't mind explaining, what exactly does the absolute do for that line again?
Oh yeah, sure. So let's go over here. So I'm going to the whiteboard. So if you think about it, we might have, I think real first and then original, right? So there might be that this is 4 and this is 7 for whatever reason, and this could be 5 and this is 1, right? But it could also be that this is 8 and this is 4. So what's going to happen is if you take the difference of all of these, this is going to be 4 minus 7 is minus 3, 5 minus 1 is 4, 8 minus 4 is 4. Do you see that?
Yes.
But when we rank this, this is going to be confusing because of the sign. Because all we need is really what is the difference between them in units. So the difference between 4 and 7 is 3. We don't care about the sign. So the absolute value just gets rid of the sign, basically. You see that?
Okay.
And that way we're able to more correctly rank them.
All right. That makes sense.
Okay.
Thank you.
Yeah. Any other questions, guys? Nope. All right. So now let's go back to the virtual machine. Okay. So thing is, I don't want to lose any packet, right? So I just want them sorting. So actually, what I'm gonna do is instead of the if directly, I'm just gonna say diff. Right? And once I have diff, I'm gonna say so there's a couple of ways that we could do this. We can create a couple of lists. Say IP list and also Ttl list, correct? Or no, diff, sorry, diff list. So then we are going to go in here and add them basically. So we're going to take IP list dot append, and we're going to append the IP source, IP src. When we do that, we're also going to append the diff. Dot append, right? And we're going to add in here the diff. Oops. Okay, once we have this, and this will just generate basically for all of our packets that we receive, we're going to create this list here. When we're done, we can write out that list or a dictionary, etc., and we can basically sort the list, right? So we're going to sort new list, new diff list. It's going to be equal to diff list dot sort. Okay, and once we do that, then we have the differences. Trying to think if I should just do this with a dictionary instead. New diff list. Maybe we should do this with a dictionary. So I'm going to do diff dictionary like that. And so we would have to create we could use the IP source to be the key, and then we just specify the TTL, the diff, sorry. All right, so that could be a way of doing it. We could also just write it to a text file and then process the text file. At the end of the day, we're going to produce this dictionary, and then we need to since this is kind of just like sniffing in the network, right? It's just hanging there. We have to write this out at the end and sort it, and then identify the IPs that we want. Any thoughts on this approach? Do you guys have a better approach?
No, I think this is good.
Yeah, yeah. So I think this is probably the best one. And then the idea would be you will need to on diff sort them and then identify the IP addresses that are the worst. So you know, if you want to save the file, remember you can always use the pickle import pickle module, and then just do pickle dump, and it'll create the dictionary file, and you can read it from another script. So let's go ahead and let's see if there are no errors. Okay. I was thinking of another solution, but it involves NumPy, and that's why I was like, and we haven't covered, you guys, some of you have probably never seen it, so I didn't want to. All right, so let's do Python HT more. Let's see what happens. Okay, oh, no, didn't like it. Permission. Go. All right, so it is doing that. Now, for also, I guess, another thing we can do so that we can actually see something going on is here in diff, we can say if diff, what do we want? We want the highest differences, right? So if difference greater than, let's say, what's a good value? Threshold.
Like 5 or 10, probably.
10?
Something like that.
Okay, so let's try, let's say 8, since you said 5 or 10. So 8. So let's say if diff greater than thresh, which is 8, and diff is already a number. 1, 2, 3, 4. Okay. And then now we're just going to print, and we would print the IP source. So we're going to say IP source. Oh, well, let's say actually, this may be a fake packet. Oh, but what do we want? We want the real ones, right? The real ones. Okay, so I'm thinking about. So do we have this wrong? Because we're trying to fight. We're trying to find the attacker, right? So what do you guys think? What should it be? What are we trying to do here?
Swap the sign less than
Sorry?
what you have there. I was saying what you have there is less than swap the sign.
Swap the sign. I got you. All right. Swap the sign. Yes. So then we would say if the difference is less than a threshold, this may be, this could be attacker IP, could be the attacker IP. Yeah, that works. And let's say then print IP source, right? We also, just for, we want to see the TTL. So let's say print, just to make sure it works, TTL, no, difference is, and then we can plug in diff here. We might need to convert it to string. Let's see if you guys have a better, can you scroll down to bottom for 1 second? All right, so I'm going to go to the bottom as someone suggested. And I guess that's all the way to the bottom.
Should that has layer be lowercase?
Which one?
Well, your get layer is all lowercase, and then your has layer is the L is capital.
I see what you're saying. That's a good question. Yeah. So probably all lowercase. Huh? But it didn't give us an error before. I think I ran it. Maybe it didn't. Let me try it. Yeah, it's running right now. But yeah, good catch. I think the correction is that I just did is the right one. All right, so we want to test this somehow. Now, I asked you guys the following question. Am I missing anything? Have I missed anything? Do you think, is there any additional logic that you guys added or that you want to add in there?
Well, if there's a private IP, it'll catch those as well.
Right, so get rid of private IPs. We need to have some kind of a list of them, right? And just get rid of them. Is that what you mean?
Yeah.
Okay. Yeah, we can do that. There's a way to do that. Yeah, there's a library for that and import IPY, import IP. But let's skip that for now. So now the trick is, how do we trigger this? How do we launch some things? What do you guys suggest?
Can you scroll down so I can see your sniff come in?
Oh yeah. Yeah, so I want to, so now we have a sniffer, right? Sniff and spoof. But how do we test it? So we need to send something to it. So I want to know if you guys,
Do a ping command.
a ping command? Okay, so
That'll
let's-
generate ICMP traffic and it'll execute your test the TTL value function and kick things off. So
Okay, so let's try it then, right? So let's see. I'm going to open up another terminal. And in this terminal, I'm just going to run my sniff, Control-X, clear. So it's sniffing. All right, so now here, right? So what do you suggest we target? So ping, right? What do we target? A local host?
That would,
And yeah, go ahead.
wouldn't you want to ping from say like another PC?
You could, I mean, you should, but in our example, right, packets from one computer or another computer, the only difference might be like if it's in promiscuous, non-promiscuous mode. But in this case, if we target it directly, the packets should be captured by this scanner, I think.
Okay.
But yes, you're right. Once you start talking about other machines, there is a setting about promiscuous mode. So it'll ignore packets that are not for that machine, so it may not do anything. So certainly that. If you want to implement this in the network, you usually do it with a tap. And what that means is that you're going to have a mirrored port. So that way you have your traffic going, let's say, through port 1, and then port 5 is mirrored. So then you can connect this device to port 5, and the device, any packet that goes through 1, it'll see it on 5. Does that make sense? Thanks.
Yeah.
Okay, great. So just ping like this, guys. Just ping. I guess let's send some pings out. And it's not capturing anything here. Well, there's no routing devices, correct? Do you think that's the issue?
I got mine to work when I just ping like pnw.edu, then I start to get some traffic from it.
Okay. So you just hit PNW. So let's try that. All right. I'm going to run it again. It's running. And you said you ping PNW. Ping www. Okay. Something is happening there. What's happening? There's no attribute TTL.
It's probably because your SR1 function didn't get a reply. And if it doesn't get a reply back, it doesn't get a TTL value back. So I'm wondering, P&W may have something blocking. You could try like 8.8.8.8 with Google and see if maybe that results in something different.
Okay. So it's listening. Probably because it's still pinging, right? Yeah.
Yeah. And actually, if you go back to a terminal, you'll see what I mean. Up at the top, finished sending one packets, received one packets, got 0 answers. So because you got 0 answers, it's not going to have a TTL value, which means it's a none type object. It's null, basically.
Yeah, good observation. So then 8.8.8, correct? Let's try that. All right, so it's listening again. Now. Okay. All right, doing something. Leave me an error.
Yeah, still not getting an answer back from those hosts.
And you guys got it to work?
I got a little bit of a workaround. It's not perfect, but if you put it in a try catch block or try accept block and do try, have all of your code and then accept, you just
Yeah.
pass it. It'll still pass and try again until, and if it gets an answer, it'll work. If it doesn't get an answer, rather than breaking it, it'll just skip past it and continue going with the next packet.
And when did you get so you eventually got an answer from 8.8.8, is that what you're saying?
No, I was using Nmap on another VM when I was doing
You did
this.
it with two VMs.
Yeah, but I've gotten the same error before, even when doing that. I think sometimes it just doesn't always catch in time or something. So having that try accept block.
I see what you're saying. So you're saying maybe. Yeah, it definitely helps to add the try catch. So let's see. Where is it erroring out? So it's getting this.
It's going to be airing out on that res_pkt, the SR1 function. That's where your error is coming from.
So then let's do try. Right, try.
Mhm.
What is it? Try accept. Yeah. Then let's do try all of this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 4. 4. 4. And the dictionary was 1, 2, 3, 4. Okay. And then accept. 1, 2, 3, 4. Print something. went wrong.
After that, you're going to want to put the pass command. Otherwise, it'll still stop and it'll just say something went wrong. Pass will cause it to move on and to the next one.
Catch. All right. So let's try it. Try it again. All right, so it's listening. Okay. Hey, it's working now, right? Or-
Yeah, so you can see it's skipping the ones that get 0 answers. It just moves on to the next one, and then you'll see information for the ones that you get an answer for that have a TTL. And then that's kind of how I've gotten around that issue.
So let's see, it's printing. Okay, so it's thinking that some of these could be attacker IPs, right? Diff is 0. So we're looking at the ones that are closest. So 0 is dead on, correct?
Yeah, because they're the same. You're not using any decoys or
They're the
and
same.
maps
So
is
anything
random.
that's a 0 is correct. It came and it didn't take a deviated path, which could be possible, correct? Like we didn't have any ones in here, but it could happen that there's a difference of 1, and that's because it went through another router, but that's very unlikely here. So it's getting through, right, guys?
Yeah, so usually the threshold is just, I've usually do like 5 or 10, just depending on what potential alternate routes it could take. And then it's a pretty good guess that if it's underneath that threshold, that it's probably legitimate.
So we would say, in theory, this is correct, right?
Yeah.
Now, so do you guys have any questions, guys? Do you have any questions? Was there something that wasn't clear, or those of you in the chat, did you get it now?
I think I got it.
Okay, you think you got it? More. All right, so somebody's asking me to go over the code again. I will in a second, but just to, so here we were able to detect a few that had a difference of 8. If we ping, all right, what about what I did initially? Yeah, so what we're doing here that ties into the problem is basically this output tells us potential bad, the real attackers. Remember, you're getting a whole bunch of packets that are scanning your network, a whole bunch of them, but they have fake IPs. So instead of looking at the thousands possibly of attacking IPs, we just focus on this. So your team will look at this because these are the ones where it's really close. Do you see that? I know I'm generating the packets with a ping, but imagine the packets are being sent by Nmap or some other tool. So it doesn't matter who sends them, they're just packets. Right, so the question here in the chat is, so this program is essentially a filter. Yes, it is literally a filter. It is a ranking. That's why I created the dictionary. You would rank the differences and then pick the ones that are closest. It just so happens that I did the thresh just to kind of visualize it right now. Is that clear? Okay, great. All right, so it seems like you're getting it. So let me stop this one because I don't want to think too much. All right, now the other question might be, yes, I will go over the code in a sec, but let's think about what I did initially, right? Initially, I did no. So initially I did ping -m 64 8.8.8, right? So I'm setting that So let's run, so let's see what happens with this one. Is it still running? Yeah, it is actually. Okay, so let's run that one. Okay, it's saying it's 56. Let's go to the scanner. It's not doing anything. How come? Any ideas why that might not be? Because it's not doing anything, correct? Yeah. But so can you guys elaborate? What do you think is happening?
So I would say that if it's looking at all the incoming or just any ping that's passing through the machine, and if it's above the threshold, it flags it.
Right. So we were looking for packets that were closed, right? So the real ones. So let's just try something. Let's see what happens if I do this. So now I'm gonna do, let's change this. Right? I'm gonna change the sign to a clear here. All right, it's doing that. And then I'm gonna go over here. Permitted. What is that? Something went wrong. Should I have done sudo for the 64, do you think? Let me try that. Okay, I'm not seeing the error this time. Sending packets. Something went wrong. So what I was trying to do is I was trying to capture the other end, right? Now the packets that are really fake. So I was thinking if I'm sending packets with a TTL of 64, but that didn't work. How can we do? I'm not using Nmap, but any ideas what we could do here? That didn't work. Do you know what I'm saying, guys? I'm trying to do the opposite. In the first example, we were able to capture the ones that are real, but now I'm trying to find the ones that are more fake. So how could we do that?
Well, currently it's not, unless you can set a TTL value that'll be different. Because so what your code had, if I'm not mistaken, you switched the sign to be diff greater than thresh, but none of them are gonna be greater than thresh because they're all gonna be 0 and thresh is set to 8. And 0 is not greater than 8, so it's not gonna display anything. But if you use it, if you hard set a TTL value to make it different from the normal TTL value, then what you have would work. But
Okay, so try Nmap maybe, right?
yeah, you'd have to use a tool like Nmap or something in order
Let me see
to.
if I have Nmap installed on here. Sudo app install Nmap. Right?
And you can skip a hard set of TTL.
I can do what, sorry?
You can use Scapy to hard set a
Right, we
TTL.
could, and then we'll have to build a packet for that. That's true. That's true. But another script, right? Let's just try app for a sec. So sudo app install nmap. Let's just see if we can get this to work. It's taking a while. Okay. All right, so I seem to have it, correct? So let me try this one now. So I'm gonna do script here, right? Sudo Python 3 hdmore. Listening, okay. Let's go to the other terminal. I should have nmap now, so let's do nmap map. $127, is that what you guys? How did you guys that wrote the nmap command, how did you do that?
To set the TTL.
Well, the TTL is just, I think, something like that, right? TTL.
What I did was I did sudo nmap. I did just any random type of scan, so like -SS.
Give me a sec.
And
So sudo nmap
Yep.
dash
Lowercase s for the first one, uppercase for the second one, doing a sin scan. And then dash TTL, which you already have there. So yeah, if you set it to something, whatever you want to set it to. And then if you do after that space dash capital D for decoy, you can actually set some decoy IPs too. Dash capital D. And
Don't
then
you
you can
have to target 8.8.8?
Yeah, I mean, you can target whatever you want to. This is just a decoy scan. If you wanted to, you could use whatever IP, but this is to do a decoy scan, so you can specify.
So this
decoy
works, you're
IPs.
saying, that just like this, it'll work.
If you use the -D parameter, you'll need to include at least one decoy IP, but other than that, yeah, you just need to specify a decoy IP and a target. So that's your decoy, and then if you do space and you type in the target IP address.
Did you target 8.8.8?
Yeah, whatever you wanna attack.
I don't want to attack 8.8.8. To be honest.
Yeah.
Did you actually do that?
No, like I said, I had a second VM, so I used a VM to
I don't
attack.
actually want to do that on with this one, to be honest. But in theory,
In theory, this is how you would do a decoy scan with nmap.
I'm a little reluctant to do that.
Yeah.
So just in the interest of this, so you think this command looks correct, Dakota?
Let's see. Yeah, as far as I can tell, I think so.
All right, so let's run the scanner here. Let's just see if this actually triggers it.
Usually takes a couple minutes, or not a couple minutes, a couple seconds.
All right. It's generating something.
So you should get something from your legitimate IP. If that decoy IP address isn't actually a live machine, you won't get an answer. So it'll just say got 0 answers, something went wrong. But you should get something from the source IP, which is your IP address of your virtual machine.
I'm not seeing anything. All right, I'm gonna kill that one.
Yeah, well, I think it stops itself.
Yeah. All right. So So this is basically the idea. So now all that remains for you guys to do is you have to show, you have to have a couple of machines at least, and show that there's some of the packets that are not aligned, or sorry, some of the packets that are decoys, identify them, and then some of the packets, because what might be interesting when you do that is that it'll have different IPs because they were decoys. And then we saw the other one where they were the real IPs. Okay. So are there any questions, guys, on this one? Does it make sense? Is there anything you didn't get?
So we just need to show that we can identify decoy IPs and that's it for the problem, or?
Well, yeah, so this is basically the whole thing. Just work, now you have to work through the scenario, right? And you have to think, you have to, yeah, identify, as we did before, the ones that would be the actual, IP, the ones that are close in TTL, and then the ones that are, some of them that are decoys would be nice if you show the IP of them, like this is a decoy. So here's the IP of it, just to kind of see that, because it would show a lot of different IPs, correct?
Yeah, I mean, whatever decoy IPs you use, it'll
Yeah.
show.
Yes, exactly. So that's the problem. Remember, a lot of the time with these problems, you have to have the network set up in order for it to work, right? So you have to, but this should be the main idea of it. The other idea that was suggested is that Ryan had was just to create the packet from Scapy. You can also do that if that's easier for you. Some questions. If you've submitted, you can always resubmit. I'll just grade the latest version. I also was asked if this would stay open on Saturday until Saturday. Yes. So remember, assignments are due tonight with a soft deadline and then with a hard deadline on Saturday. Make sense?
Yep.
Okay, so is there anything else you need for me to explain about this problem before you can complete it on your own? Is there anything else you didn't understand? This is, I think it's clear enough now, but I'm asking, is there anything else? That you want me to? All right, so somebody asked me to go over the code again. Okay. Let me kill it. Make sure I don't have it now. All right. So unmap it. I'm gonna actually just close this. Okay, I'm not sure why it's doing that. All right, and then, all right, so I've got one terminal here. So let me see what is in the file. We're gonna open up Ph.D. more. All right, there we go. So, that someone asked, what's the code? So remember, these are all gonna be like this, sniff and spoof. So basically, you start with a sniff. The sniffer, remember, if we go to the whiteboard, so let's go to the whiteboard. You have to remember that you've got packets, right? You've got let's imagine you've got a sniffer here. And then the sniffer doesn't care about anything. It just cares about packets. So initially you sent a packet to that 8.8.8.8, correct? With the nmap function. This went out, so it sees it. It's gonna see that packet. Then 8.8 will reply, because this was a ping packet or something like that. No, it was an nmap. It will also see that one. And when it sees that one, it'll grab it. So both times it grabbed this packet, which was headed in that direction, and it grabbed that packet. Oops. All right, so this is what you're sort of comparing here in the scenario. Okay, so if we go back to the code, we have a sniffer. It picks up ICMP packets. Whenever it grabs a packet, it sends it to this function, test Ttl value. So you have this function over here. You have the packet. We check that it is a IP packet. Then, because it's an IP packet, we get some values from it. We get the source IP, which we save in this variable. We also save the TTL, which we save in that variable. That's the packet that we saw. Okay, that's the packet that we saw in that scenario. So actually, one better way of doing this probably would be to say something like ICMP and the specific packets coming back to you, right? Because then it's just going to look at those packets, the ones that come in, and then you're going to do the process of sending that back out. So it might simplify things even more. So you get here then the IP source and the TTL. You pass those to check TTL. So you go over here to the check TTL function. We create the new fake packet, not the new fake packet, but the new spoof packet that it's going to help us to check TTL. So we do IP. The destination now becomes the IP source. It's an ICMP packet, so that's packet spoof. Then we go over here with this function SR1, which allows us to send and receive. So we send the PKT spoof. We get this one, receive packet. We grab the TTL from it, call it the actual packet, because actual TTL, because this one should be real. And then now we take the difference between the original TTL, which was in the packet that we received, and the actual TTL, which is this one. We convert them to int, take the difference and absolute value to get rid of the negative. And now we can just play with diff and threshold. So really, since we only want the real ones, we should pick where the differences are small, okay? Where the differences are small. And then once we have that value, we've identified it. So then we just print it out. We print out the difference, we print out the IP source. Later on, you can also save it to a dictionary, save the dictionary to some file, or for further processing, like ranking all the divs, etc. And that's it. We did the try catch because we were getting errors and it was breaking the code. So that just ignores what we were doing. Is this clear, guys? Are there any questions?
No questions.
All right, great. So it sounds like the code is clearer now. Okay, great. So that's it. So that's now you have the code. I've demoed that it kind of works, right? Now it's up to you to, as I said, provide, create cases or scenarios within your environment where you find the real ones, right? So you can tell me, hey, this is how I did finding that this is the real attacker. And then also run other scenarios where you say, hey, here's just on a sample basis, here's a few fake ones, and you can see the TTL is pretty big. And that's it. That's what I want you to do with this homework assignment. Okay? Questions? All right, so it doesn't sound like there's any questions. So remember, you have until Saturday to finish, so that should be enough time. All right, and then the other part of the assignment is if we go back to Brightspace, so let me just close this file now. Okay, so let's go back to Brightspace. All right, so you should be seeing Brightspace. Oh yeah, so all you have due Saturday is this HD more. Okay, I forgot. So that's, and then the homework that's due a week from today is the one related to the sniffer. So you have plenty of time. So this one, I was thinking that these were both due today, but they're not. All right, so sniffing, we talked about this in great detail on Tuesday. Pretty much, I think I went over a lot of this. You have sniffing in C++ and Python. So are there any questions about this other homework that's due a week from today? Okay, doesn't sound like there's any questions. Great. So that's basically it for today. That's the lab. I'll stay until the end of class. If you have any questions, you want me to help you with something. Otherwise, I don't have any additional material, and it's just an open lab. So let me go ahead and stop the recording at this time.